How many of you have heard of urban computing? It's computing in the city, right? So Microsoft Research has a big group on this, and they've done some amazing stuff. I think one of the groups is in Beijing. So what is the main idea here that becomes super valuable is when you start combining data from multiple sources of information. This is when you're going to really cross some kind of barrier, right? So it's, for example, you could have OpenStreetMaps or Google Maps giving you the maps, and then you have location data that tells you where a particular person is. If they're using the maps, of course, you know it, or maybe they tweet it, so you only know, they tweeted from this location. And of course, you can take that point, the lat long point, as Ram pointed out in his talk. You can actually do what's called map matching. You can just throw it on a representation of, say, the OpenStreetMap, which I believe Magellan can read now, and then put it close to the closest footpath, cycle path, whatever, road. So that will help correct the GPS, but it also gives you a lot more information now, right? So if you get two locations, you know which direction they're moving in, for example. And from targeted marketing point of view, you will know what are the stores nearby and things like this. So of course, social media data can be fused in with location information, and there'll be sensors, right? And how much gas you have left, blah blah blah, right? So all these things can be integrated. Concrete problems like smart transportation, urban anomalies, detect collective anomalies based on cross-domain data sets, right? So there's a really nice paper here where in New York City, they're looking at 311 calls. I think that's the number people call in New York to complain about stuff. Something working, someone's parked outside my driveway, whatever, right? So you can see that live streaming because New York is an open data city. You can take that, you can, like you guys know already how to focus on the streaming API. In fact, you can put a geolocation, which I haven't shown you yet, but you can do that. So you can just start collecting tweets from a particular location on the planet, and then you can combine people maybe complaining in Twitter about something. And then they even had, in that paper, they even had the bike, people taking bicycles and dropping them off. This is rental bike data. And I believe some other taxi data. They've used all of it to actually try to predict where a traffic jam is about to happen. That's pretty cool. So anyway, I think let's see how it goes, how much energy I have tonight, but I could try and get you guys into this 10,000 taxis in a period of 1 week in Beijing data. So we analyzed it last year. So that's quite a lot of, and that's very detailed data, like every few seconds you have a beep in Beijing. Anyway, so yeah, they've used it for air quality and sort of things. Okay, so that's urban computing, and for those of you who sort of taking this on the video, we watched this Spark Summit East talk, Introduction to Magellan by Ram. So please watch it on your own. So if we want to say you watched talk like that, it's of interest to you. Now, what should you do? So you want to get your hands dirty. So this is actually a February 16th blog by him, as more recent thing on Magellan. So Magellan is a distributed execution engine for geospatial analytics on big data. It's implemented on top of Apache Spark. So Harsha 2010 Magellan is his GitHub page. Here's your basic Maven artifacts. So if you want to bring this library in to your community edition, And here are some very basic things he was talking about: geometries, point, line, string, polygon, multi-point, multi-polygon. And here are the basic predicates currently supported: intersect, contains, and within. And here are some basic examples of how to read data, various data structures. So ideally, we want to start playing with this in a sort of notebook environment. And spatial joins. Okay, so let's see. Read this next. So geospatial processing made easy. I think this is the one where I believe, yes, he's going into the New York City taxi cab dataset. Okay, so let's just sort of gloss over this blog right now. And the challenge is you guys should try to do this. And whoever has this done tomorrow can present it, right? I can help you as well. I'll also do it. I haven't done this yet. This is a little more recent stuff. Okay, so this means, okay, the first thing is let's make sure we can find Magellan. So just let's go to the community edition, and I think I threw in let's see what's here. So you'll have to, yeah, so you see Harsha 2010 Magellan. So if you go and you do the usual thing, you should be able to find it. Just type in Magellan in Maven, right? So shared, import, or sorry, create library, and follow this path. Let's go. I didn't find it this morning. Crazy.
Can't you use the coordinates?
Yeah, I can use it. So I don't know why it's not. Yeah, so I can use the coordinates. So yeah, you can just put the coordinates here. That's what I did earlier. Unpredictable behavior. So anyway, you can put the coordinates there, copy that, and put it there, and you should be able to get it. So I, for example, already have it. These are my libraries. They have Magellan. Okay. So anyway, so if you open this notebook, so I found this basically by reading the blog more carefully. I'm sort of doing it non-sequentially now, but here is this Databricks notebook for essentially the README file in the GitHub for the basic geometry, for the predicates, and so on. So this is essentially how I would sort of get into, once I import the library, just make sure I can do the basic representation of the basic objects, and then do some, contains or within predicate operations, and then some joins. And then you're able to do, you should be able to do this stuff, right? So let's see what he's doing with the taxi cab data. And the taxi cab data, I started looking at it. So here's the taxi cab data from New York City. So this is used a lot. So I was at Google Cloud Summit, and pretty much a lot of people have this as their live example. And so for hire vehicle trip, records include fields capturing the dispatching base, license number, and the pickup date, time, and taxi zone location ID. Generated from the history trip record results. Yellow and green taxi trip records include fields capturing pickup and drop-off dates or times, pickup and drop-off locations, trip distances. So, okay, let's say we do this yellow, January 2017. Let's just make sure we can open this. Whoa, 815 MB. So there is a problem, like so there is another notebook, Databricks notebook. If you read the blog, you will come into. He has this blog, but you see he's using an S3 key. I mean, there's a S3 bucket in Amazon where he's put all the data into. So this won't work for us, this command, right? Because we don't know this key. So we'll have to take maybe 1 month or something and put it back up and try out something in the community edition. This might work. Yeah. All right, so let's just continue looking at this. Okay, so and then he says he's spun up, so he's only looking at the trips in 2015, so it's a whole year. And then he spun up a 5-node R3X large cluster. We don't have that. On the community edition, we have a lot less. So maybe we can only look at 1 month, maybe. So yeah, so using 20 cores. Okay, so here is the Databricks notebook that I just showed you. So if you go there. So our goal is to analyze the trip data and figure out which neighborhood in New York City have the most frequent trips. Most frequent pickups, what times of the day are popular times for cab pickups from, say, LaGuardia Airport, and answer other questions that have to do with the distribution of cab rides by neighborhoods in some part. Okay, so he's mostly going to be using 2 main data sets. The other one is New York City neighborhoods. This is the boroughs of New York, so this is your sort of files. And I think this is very small, so you can grab that here. It's just from his GitHub, right? His New York City neighborhoods in GeoJSON. And yeah, so now he's loading the trip data from S3. So he's already figured out the schema. So this is a structured CSV file. So he's sort of looked up. We haven't done this quite yet because we just used the automatic schema inference machinery. And often you don't want to do that when the data set is quite large because it's a double read. So to first read just infer the schema and then again read. So if you know exactly what the fields are, especially like CSVs that are pre-structured, then you would go down and set up your own schema, right? It's essentially a struct type, array, struct field. So you can specify, whether it's a string type, and true or false means whether it's nullable or not. And pretty much everything else should be straightforward. So because you already are hardwiring or your schema, you know what it is, it's just going to be one read, and so it will be much more optimal. So here's the read with the known schema. So that's almost the same as before, except we just put in the schema that we just created. Okay. So anyways, just doing an action. So there's 146,112,989 rows. So that's 146 million reads in 3 minutes. And then he loads in the neighborhood data from S3. And so here is just saying SQL context read. Format is Magellan. So this is very convenient. And then the option is GeoJSON, type GeoJSON, and then he's loading the neighborhoods. And selecting the polygons, the metadata, and caching this. So And then there are 310 boroughs of New York City, or polygons. You can also get an estimate of how jagged, and then finally is doing a join. In order to determine which neighborhood each pickup point falls under, we need to join the trip dataset with the neighborhood dataset. Okay. Yeah. So if we do it naively, if M represents the number of points, N the number of polygons, and P the average number of edges per polygon, then the computational complexity is OM and P. Okay, so I think he basically does the join. The 5-node cluster without whole stage code gen, it takes 6 minutes, and with whole stage 2 minutes. Okay. All right, so that's this large data set, but I have something almost the same, except it uses, if you continue watching that talk that we started to watch the first 15 minutes of, it'll take you, he's analyzing another data set, which is a San Francisco data set. Or maybe it's this talk actually, sorry, it's this 2015 Spark Summit in Europe talk. And in this data set, he's analyzing Uber data, not New York City taxi data. And so what I want to make sure you guys can do is go down to the bottom of this notebook and make sure you can download all of this. So this would be a very safe thing, so you can do almost the same thing, except it's San Francisco neighborhoods and Uber trips, and it's a much smaller data set, so you won't run into resource problems. So I'm just getting this Uber data, and as you see, that pulled down very quickly, and yeah, it's not very big. So I'm in my Databricks driver. So I'm going to make a directory called Datasets Magellan, and I'm going to copy all.tsv tab separated value to this directory. So now I've moved my data from local file system to the distributed file system. So then I think this should still work. So it's my yes. So in the redirect, so this is just the neighborhoods, San Francisco, in GeoJSON format. Oh. Anyway, I don't really need the other one. Okay, so and then I unzip it. Okay, so this is the shape file. This is not the GeoJSON. So this is the other. And I'm simply going to move the save it, and now I'm just making a directory and moving all of them into into this directory, and just now making a directory called San Francisco neighborhood in the DBFS. This is just silly, but you can do it better. And if it's GeoJSON, you can just directly read it. Okay, so now I should have all of my, so a lot of your legacy data, geospatial data will be in this format. Right? It's actually a whole bunch of files that tell you different things about the same data. So anyway, this is good. So you have the Uber trajectories and the neighborhoods, and you watched sort of the 2016 Spark Summit talk. That's kind of enough. And if you watch this sort of second half of this other 20-minute talk, you'll see what he's doing with the Uber data. He's doing exactly the same thing. When did this trip begin? How many are there in each neighborhood of San Francisco? Stuff like this. And I actually have the code that was working earlier, right? But this is Spark and 0.3 and older version of Measurement. Okay, so I don't know if it will work. Probably not. So so you can try to, or I'll do this myself. So we can just make sure that this works. And if you're brave, maybe try the New York one. Maybe just take a month and play the same game. That'll be good. And so in the first 20 minutes or so tomorrow, I will go through this, finish it off, and I'm not sure what's coming. Oh, right. So we were going to, so I was going to show you guys this last step. Remember this power plant pipeline we were doing? So we did the model, ETL, tuning, tried out linear regression, and gradient boosted regression trees, and found the best model. And last time, actually, the model wasn't quite running, right? So if you remember, it took a long time to run the model. So that's what I have done today, this morning. So we did linear regression, and then we said we have to do some regularization to find then we did cross-validation to pick the right hyperparameter. And then we realized, okay, we're not really improving much. And then we said, okay, let's go and look at something besides regression. And we did gradient boosted trees, right? And then in the gradient boosted trees, I think it took almost 16 minutes this morning. And I think it'll take a lot longer on your community edition. But we were able to improve the error quite a bit. And the last thing I wanted to show was once you have your best model, this is the one. Once you have your best model, you want to be able to do predictions. Right, so this took 13 minutes and 48 seconds this morning on a shard with 6 nodes, the academic shard. And the neat thing was the root mean square error is way smaller now. It's 3.7 as opposed to 5 point something. So this is our best model, and it uses something like 120 trees in this ensemble. And so then what I wanted to show you was deployment. So now you have this thing that's ready to go. And usually you will save this in a format. Save the trained model in a standard format. Actually forgot to do this. So this way you don't spend another, so many minutes to do this, and you can trade that file. That's just a pure text file, pure file in some standard format, so you can trade it. And that's exactly what happens when you download the Google's machine translation API from the cloud. It's one of these, the deep neural net that Google has trained. You just get a snapshot of it. So now you can deploy it. Unfortunately, one of the libraries is not installed in Databricks Academic Shard, which I cannot directly install, so I can't show it in action yet. But you basically choose the final model, and then you create your little table here. And as data is coming in, one of the libraries is installed, we can serve predictions live. Okay, so we'll do this later. So then we've sort of used all the different parts of the process. Okay, this is the deployment phase where, queries are coming at you from the power station, and you have a pre-trained model that you load back in, and then you just serve your predictions live. So I'll do this in the end, so we sort of complete circle. And I will most likely do structured streaming for the second half of tomorrow. So structured streaming is a new thing in Apache Spark. It's like everything is more structured into data frames, and so and Spark streaming is more RDD based, low level stuff. That's what we just did. Any questions? So does anyone want to volunteer for tomorrow's Uber or New York City analysis?
I'll try.
Okay. Okay, good. Yeah, okay, good. Okay. Yeah, good. Yeah.